Inhalation of smoke from cigarettes causes nicotine and other active substances to travel to the lungs and eventually enter the bloodstream. The nicotine then carries out its effect on the central nervous system by interacting with specific receptors in the brain. Nicotine acts as an agonist at the nicotinic acetylcholine receptors. In the brain, nicotine interacts with these receptors, located on dopaminergic neurons of the mesolimbic pathway. Binding of the nicotine causes the ion channels to open, creating a passageway for calcium, potassium, and sodium ions. This results in the generation of an action potential, which travels down the axon to the terminal and causes increased calcium ion entry. This then causes dopamine-containing vesicles to fuse with the neuronal membrane and release dopamine into the synaptic cleft. The dopamine binds to its receptors, triggering its reward-like effect. In most cases, the brain responds to nicotine by building a tolerance towards it, meaning more nicotine is required to raise dopamine levels again in a person addicted to nicotine. Without the presence of nicotine, the person may feel stressed or in a bad mood. The intake of nicotine, however, will cause dopamine levels to rise again, causing a stimulation or euphoria. This thus explains the resultant craving and addiction properties associated with nicotine. CNS toxicity caused by nicotine is usually as a result of overstimulation of the nicotinic acetylcholine receptors. As nicotine is effectively very similar to acetylcholine, an excess amount of nicotine will cause a buildup of nicotine and already present acetylcholine in the synaptic cleft. This can then bind and activate other cholinergic receptors throughout the nervous system. Toxicity caused by nicotine excess is known as nicotine poisoning, and the consequences can be lethal.